Hello and welcome to the practice problems video for the section on rational functions. Okay, number 1 asks us to find for this function horizontal, vertical intercepts and vertical horizontal asymptotes, and then we're going to use all of that information to sketch our graph. Okay, so because this is in a nice form to find horizontal asymptotes, then let's do that first. Because we can already identify our leading terms, right? Because we can see that, well, our leading term on the top is going to be 3x squared, and the leading term on the bottom is also going to be a 3x squared. So we can cancel those out and kind of just look at the ratio of the coefficients, of the leading coefficients, and that gives us 3 over 3, which is equal to 1. So our horizontal asymptote is going to be y equals 1, okay, the line at the height of 1. Okay, so now what we have to do is actually factor. Yeah, I know, I'm sorry, we have to do a little bit of math here. But anyway, so let's just factor the top and the bottom out. So we have 3x times x something, and then on the bottom we also have a 3x times x something. Okay, so for the top we need it to multiply up to negative 5 and add up to negative 14. So we could have something like that, right? And then on the bottom we could just have negative, and we need a positive somewhere else. So we actually put the positive here. And we're going to need, so this is just 4 and a 4, but we go like that. So we should arrange it like that, so that we have plus 12 and then minus 4. Yeah, that gives us a plus 8. Okay, so this is how we're going to factor it. So in order to find our horizontal intercepts, we just look at the top. What could make the top be 0? And that would be x equals negative 1 over 3, and x equals positive 5. Okay, so our horizontal intercepts are negative 1 over 3, comma 0, and 5, comma 0. And as for our vertical asymptotes, we can find that from looking at the bottom, right? So vertical asymptotes are what makes the denominator be 0, but not the numerator. So the bottom is going to be 0 when our x is equal to a positive 4 over 3, or a negative 4, and a negative 4, okay? So, and I'll just write those as two separate things. So we have one intercept there, one vertical asymptote there, and another one at x equals negative 4. Okay, so lastly, we just need to find our vertical intercept. Okay, we found 3 of the 4 things. So lastly is our vertical intercept, and that's when our x, or our input, is equal to 0. So that we're just going to plug in a 0 here and see what we get. So on the top we just get a negative 5, and on the bottom we just get a negative 16, and for that I just looked at the top again. It's nice to have two different forms to look at and work with. Anyway, so this just gives us a positive 5 over 16. Okay, so the point for our vertical intercept is going to be 0, comma 5 over 16. Alrighty, so let me write all of this information on the next slide so we can graph. Alright, so horizontal asymptotes. Those are going to be at, or one of them is going to be at y equals 1. As for vertical asymptotes, and here we have 2 of them, those are going to be at x equals a positive 4 over 3, and x equals a negative 4. Okay? Now for our intercepts, horizontal intercepts, those are going to be at negative 1 over 3, comma 0, and 5, comma 0. And lastly, our vertical intercept, which we found last, is going to be 0, comma 5 over 16. Okay, so now let's graph. Let's do the points first. So we have something like this, x and y, and we're going to do, let's see, we have to go all the way up to 5. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Okay, so let's graph the points first. So we have 0, comma 5 over 16, so that's less than 1/2. So something like this, that's our vertical intercept. Okay, got that out of the way. And then we have a horizontal intercept is negative 1 over 3, comma 0, so like right there, right? We have 5, comma 0, so 1, 2, 3, 4, 5, all the way over here. And now we're just going to draw in our our asymptotes as kind of like guidelines. So we have one horizontal asymptote at y equals 1. So that's a little bit strange, right? Because we have it cutting through right here, okay? We also have another one, we have 2 other ones, actually, the vertical ones, at x equals 4 over 3 and negative 4. So negative 4 would be all the way over here, right? So something that goes through like that, Okay, and then we have one at 4 over 3, which is in between 1 and 2, so something that cuts through somewhere about here. Okay, so if we go back to our factored form of our function, we see the following. So we had 3x plus 1 times x minus 5 over, and this is the important part, 3x minus 4 times an x plus 4. So we see for each of these, this one gave us x equals 4 over 3, and this one gave us x equals negative 4. Those gave us our vertical asymptotes. For each of these, we had a power of 1, right? Which means, because it's odd, that means at each of these vertical asymptotes, we have opposite behavior on either side, okay? So we have something going up and something going down on one side of the asymptote, or we have something going down and something going up, okay? So as for that, now we can just kind of connect some things. And if you want, we can always, like, on this other section on the left side, because we have points in here, we have points in here, but we don't have anything over here, so we can always, like, graph a point if you'd like to, but it'll basically just look something like this. Okay, it'll be up there above 1, okay, if you're just plugging a point. And then in the middle, we have something that looks kind of like an S shape, sort of. It goes down and, like, approaches the asymptote on the left over here. See how at x equals negative 4, this vertical asymptote, we have unlike behavior, right? Because on the left side, we have it going up to positive infinity, and on the right side, we have it going down to negative infinity. So it's going to be doing exactly the same thing at this asymptote, this vertical one, at x equals positive 4 over 3. On the left side, it'll be going up to positive infinity, and on the right side, it'll be going down to negative infinity, okay, as we approach this x equals 4 over 3, okay? And that's what our graph looks like.